Alright, I'm going to try and go through the practice test for y'all to see, for you guys to check it against. Now, if I have triangle RST and triangle JKL, this is 3 pairs of congruent corresponding sides and 3 pairs of congruent corresponding angles. What you might want to do is actually just draw those in, just so you can see them. RST and JKL. And right away, you know that R and J are going to be in the same place, lower left, or upper right, upper right. It doesn't really matter. As long as you realize that angle J, actually I should say R first, is congruent to angle J, and then angle S is congruent to angle K, and angle T is congruent to angle L. And then we have the sides. RS corresponds to JK, and they're going to be congruent. So RS congruent to JK. ST congruent to, let me make that a T actually, congruent to KL. And then the bottoms, RT and JL. Three pairs of corresponding angles and sides. Complete each congruent statement. So S is congruent to G, so we'll put a little mark right there, little mark right there. Then A corresponds to R, we'll put 2 marks right there, 2 marks right there, and then T would correspond to E, so I'll put 3 marks right there and 3 marks right there, just so I don't get confused. And then that would make SA congruent to GR, and then AT congruent to RE, and then the last side ST congruent to GE. So angle S is congruent to G, AT, the bottom, is congruent to RE, the bottom. Triangle REG, we're doing REG, what corresponds with R is A, what corresponds with E is T, and what corresponds with G is S. GR is corresponding to SA. Triangle ERG is corresponding, E corresponds to T, R corresponds to A, and G corresponds to S. Angle R corresponds to A, angle E corresponds to T, EG would be this side, and then E corresponds to T, and G corresponds to S. The order matters, people. State the postulate or theorem you could use to prove the triangles congruent. If the triangles cannot be proven congruent, write not possible. So right here we have an angle, a side, and an angle. Angle, side, angle. That works. Right here we have 3 sides corresponding to 3 more sides over there. So side, side, side. Right here I have a side, pairs, angles, and then they share a side. So that would be side, angle, side. Down here we have angles, angles, and then I see that they're made by cross lines, so we would say that these could be congruent, but that's not enough. AAA, that's not one of our congruence theorems, so we're going to say not possible. Moving on, I have angles, angles, and a side. If I go around the triangle, I start with this angle, then I come to this angle, then I go to side, angle, angle, side. That works. Then I have angles, sides, sides. Let's look at the order. If I start at this angle, I move to this side, then this side, angle, side, side. That doesn't work. Only way it would work is if this was a right angle, and then we would know the hypotenuse and a leg. But because that is in the hypotenuse leg, it doesn't work. Alright. In the diagram on the right, triangle PQR is congruent to triangle SRQ by side, angle, side, meaning side, angle, and then this would be the other side. What other parts of sides and angles can you conclude are congruent by corresponding parts of congruent triangles are congruent? So basically the ones that aren't marked. So I can say that angle P is equal to angle S. And then I can say that PR is equal to QS, or I should say SQ, put it in the right order. And then this angle right here would be congruent to this angle right here. And this angle right here, I'll call it PRQ. And this angle, I'll call it SQR. And that is about it. Complete the plan for the proof. So isosceles triangle JKL with JK being congruent to JL. Okay, and KM and LM are bisectors of the base angles. Okay, so prove that KML is isosceles. So our plan is, since triangle JKL is isosceles, JKL is congruent to JLK, and that is by the isosceles angles theorem. So triangles theorem, sorry. Since KM and LM are angle bisectors, so KM, LM are angle bisectors. Angle MKL, so MKL is LKL, MLK, so that's congruent. They have to be. Therefore, triangle KML is isosceles by, okay, that's what they're saying. So this is congruent to this. And then if we know this, these two angles are congruent, then we know these two sides are going to be congruent also, because that is the converse of the isosceles triangle theorem. Isosceles triangle theorem says that if we have two sides that are congruent, then the two bottom angles are going to be congruent. And then the converse says that if we have the two bottom angles being congruent, then these two sides are going to be congruent. Going backwards. 6 triangles are pictured in the diagram at the left. Which of the triangles are isosceles? So, if this angle is congruent to this angle, then I know that this side is equal to this side. So right away, that would encompass triangle AED, the big triangle. Now, if this angle equals this angle, then these two angles would be equal because they are the congruent supplements to these angles with a double mark. And if these two angles are equal, then these two sides are equal, which makes this triangle EBC isosceles. And that is it. Alright, we have to prove angle MLN equals ONL, right away I see that I have parallel lines. So I'm going to look for alternate interior angles. I see that if this is the transversal right here, then this angle and this angle are alternate interior angles. And then I'm also given that this side from here to here, LO, is equal to MN, and that's just marked, so I have a side. And then I see that this triangle has a side shared with that triangle right here, LN. So, statement, reason. I'm going to say, first of all, that LO is parallel to MN, and that's given. So the first thing I said, because of those being parallel, I said we have to look for alternate interior angles. Angle OLN is congruent to MNL. Because they are alternate interior angles theorem. Then I said that OL is congruent to MN because it's given. And then LN equals LN. And I shouldn't have drawn an angle. Because of the reflexive property. Right there I have a side, an angle, and a side. That's enough to prove that the two triangles are congruent. So triangle MLN is congruent to triangle ONL because of side, angle, side. And then I can show that they're congruent parts. Angle MLN is equal to ONL because corresponding parts of congruent triangles are congruent.